Okay, good afternoon. Happy Monday. Welcome back to the few folks who managed to get here on Friday, and welcome for the first time to the people who weren't here on Friday. I'm going to apologize on behalf of somebody, I don't know who, but there was a mistake made when you were sent your schedule, and it said that this class had its first meeting today, whereas GCC opened on Friday and classes met on Friday, and I don't know why this happened. I sent an email to somebody over in IT, and I see that actually it has been corrected retroactively. Now, we have started on Monday, but it's already passed. So how do we fix this? Well, here's what we're going to do. I will say that there was homework due today. I'm not expecting it from the people who weren't here on Friday. I will expect today's homework from you guys on Wednesday, okay? So you got a homework assignment. I will show you where it is, but we'll make yours due on Wednesday. In terms of what you missed, well, there's a few handouts that you'll find. Did everybody pick up the 3 handouts today if this is their first day? Okay, so one of the handouts looks like this. At the top it says Math 106, and this is called the syllabus, and it has lots and lots of information. We probably spent about 3 or 4 minutes in class on Friday working through some of the highlights here. I don't want to spend another 3 or 4 minutes right now working through them. So here's what you're going to do. It turns out that I record all of my classes. You see I've got a Bluetooth in my ear right now, and I recorded Friday's class. And if you know where to go, you can find Friday's class. And part of the homework for the people that weren't here on Friday is to go on YouTube and watch Friday's class, okay? So here's how you type it in. You might want to make a note of this someplace. This is Math 106, so you start by typing 106. It is the year 2012. And then you type, I'm sorry, it is not the year 2012. Yeah, okay, so I accidentally misnamed this one, but I consistently misnamed it today as well. So for today and today only, you are typing 2012 up there because I forgot it was 2013. And then you're typing the date of Friday's class, which was January 25th. And so if you type exactly that thing with no spaces, and you hit enter, up pops my video right up here. And if we click on this video, and then turn the sound up, so you could see I was a bit surprised by the low numbers on Friday, but it was what it was. Again, it is not your fault, but if you weren't here on Friday, you're going to make up for it by pretending you were here on Friday, and watching that video is the best way to pretend, okay? Yeah, it's in the syllabus as well. Thank you for pointing that out. Yeah, the format is always going to be in the syllabus, except it will be 2013 from now on. I was still in 2012 mode. So in this video, you're going to watch the video. You'll follow along with the big packet. Today we start the big packet on page 6. So if you could open the real big packet to page 6. That's where we'll begin, but when you watch this video, you're going to open to page 1 and you're going to fill in the blanks. And when I say on the video, all right, work in your groups on this for a few minutes, you're going to pause the video and you're going to work for a few minutes and see if you come up with something, and then you're going to restart the video. I expect that people will have questions about the syllabus that weren't here on Friday, and I expect that those questions will come in on Wednesday. So bring questions, all right? Read through the syllabus, watch the video. I provide what I think are a lot of good resources for this class, so use them, and we'll try to do our best to kind of make up for this snafu on Friday. And again, I apologize. It's not your fault. Not your fault. All right, so that said, today is the first day that the red folders are making their appearance. So everybody, whether you were here Friday or not, is going to grab one of those big rectangles on the folder and put your name at the top. And this is where you're going to take your attendance every day. So just everybody write their name at the top of one of the... Absolutely no penalty for the absence on Friday. You can put that you were absent, but I'm not going to count Friday's attendance because it's not your fault. Okay, so everybody signs in every time you get here. You just write down the time that you get here, and that's how we'll take attendance. Now, in terms of the homework, so let me be clear for the people that weren't here last class. If we could actually go, yeah, right up to the top of page 6. This will be helpful even for the people that were here, just to be clear. So at the top of page 6, you'll see this key phrase, learning objectives after class number. And that phrase appears all throughout these notes, and that's going to tell you exactly where the homework assignment is, okay? We had class number 1. It just passed. In the syllabus, you will see a big old document with lots of information. This is inside the last page of the syllabus, and it tells you that today, January 28th, is class number 2. But we're talking about class number 1 right now. So we'll go back to here. And there were a bunch of things to do for class number 1, which if you weren't here on Friday, you're going to do over the next 2 days. You're going to read from the textbook a certain section. There are page numbers there. If you do not yet own a copy of this book, there are 2 copies of this book sitting in the bookshelves right across the hall in the math studio. If you need help finding them, ask the faculty member who's on duty. There's also a copy of our book on hold or on reserve in the library. Okay, so if you don't have it yet, take a look at one of those 2 places. If for financial reasons you're going to have difficulty getting this book at any point during the semester, please come see me privately and we will see what we can do. Yes? Technically, they're not supposed to leave that room. Yeah. Other questions? Good question. Okay, you're going to read the syllabus that I just handed to you and you're going to come back to me with questions if you have any. Here's the homework that I check. Let's see, there's a group activity, but I don't actually collect that or turn it in, but I do think it's important to do it. You'll find that on the previous couple of pages of this big packet. Then there's stuff in the textbook, which in the first few minutes before class, maybe you saw me walking around and checking the homework for people that were here last class. You're going to do all these problems. You can write in the textbook, you can write in your notebook, wherever is convenient for you to write. And then in the 5 to 10 minutes before class, I'm going to check as much of that as I can. If I don't get to you, maybe in the 5 minutes right after class, we'll check the work. If you want to turn the homework into me and you don't want to spend any time before or after class, that's okay too. You can just put it in the folder. But if you're doing work in the book itself, then I suspect you don't want to rip those pages out. So that's why we'll do it together right before or right after class. And then there were just some announcements and reminders and some questions I want you to answer about the syllabus. But right in there is all the homework that was due today. I'm expecting it from many of you on Wednesday. And then there will be another homework assignment that we have today. If it's too much to do, maybe by the end of this week, we can get everybody straightened out, okay? Don't stress over having 2 homework assignments for today. I know it's not fair. It's not your fault. If you need another couple of days, we can work it out. Okay. All right, so we begin here around the middle of page 6, and I'll just highlight one other thing. It says class number 2. That tells you where we start today, okay? Every day is numbered. Today is class number 2. At the end of today, we'll see learning objectives after class number 2. So I'm really hoping that the way it's organized will make it easy for people to pick up if they miss a class, if they're not sure where we are or where we're going. Okay, so can we begin? You, sir, can you read number 1 for us, please?
What's the major advancements using algebra over algebra allows us to generalize processes or patterns in the world. In order to fully utilize the power of algebra,
thank you. Going around the table, can you read number 2, please? Thank you. Dave. Thank you. Dan, number 2. Hi.
Inches represent the number of inches that snowed on Sunday and the number.
Okay, so let's give this a shot. Can you join this table right here with only 2 people on it instead of joining the 4? Thank you. Okay, now it is possible that some of you already know how to set this thing up using 1 variable only, and that's fine. We're going to do a number to algebra thing as a process. So let's take a look at it again. We have a 2-day period, Sunday and Monday, where it snowed a total of 21 inches in Franklin County. And the thing is, I don't know how many inches it snowed on Sunday versus how many it snowed on Monday, but would you buy that they're related to each other? Like, I mean, if you know one, you probably could figure out the other one. Well, that's kind of what we're going to do. So let's just make up a number here. For the number of inches it snowed on Sunday, make up a number for us. Go ahead. Can you pick a number? All right, can you pick a number? 6. 6 is good. So if it snowed 6 inches on Sunday, and we know the total is fixed, it's given 21 inches. And we figure out how many inches it snowed on Monday. We can. So without saying the answer, I'm not so interested in the number. I want a process. Can you guys like write an English sentence here, just a little description? if it snowed 6 inches, how would you calculate how many inches it snowed on Monday? See if you can write something down. If you're not sure what's happening, just check in with your neighbor. Write something in English right there. Okay, so let's get some descriptions here. Given that it snowed 6 inches on Sunday, how do we calculate how many inches it snowed? What is it? 21 minus 6. That seem reasonable? 21 minus 6, that's what we do. So maybe I'll say here in words, we subtract the 6 inches from Sunday from the 21 total. I think that's just a little bit more wordy of where those two numbers came from. Subtract the 6 that we were given from the 21, and we're left with 15 inches for Monday. Fair? Okay, so let's pick a different number. For example, maybe it snowed 13 inches on Sunday. So again, don't focus so much on the number, because I think you can get the number very quickly so fast that you're not really even sure what you did. And I just want us to slow down and really think about what we did to get the number, as opposed to just diving to the number. So can you write something in English here? And again, it's going to have the word subtract in it. So just write a little phrase in there that tells us how to calculate the answer for the last column. So it doesn't have to be word for word, but I'd like us to get in the habit of starting to write words. So for me, it was subtract the 13 from Sunday, the 13 inches that it snowed Sunday, from the 21 total, and we get 8. And now that we've got two sentences written there, maybe we can make this big leap from the arithmetic, which has only numbers in it, to the algebra, which after all is the name of this course. So number of inches it snowed on Monday. What's our favorite letter to use in algebra? X. For some reason it's X. It's perfectly good to say let S equal Sunday, or let S equal snow on Sunday. Any letter is okay there. But now we're looking for the pattern. All right, every time there's a subtraction, every time, what number was consistent? In the blue and the purple, what number appeared both times? It's the 21. We know that we have 21 inches total to work with. So it feels like every time we're subtracting something from 21, subtract something, I don't know, from the 21 inches that we had in total. So what were we subtracting from the 21? Well, in blue, we subtracted the 6 inches from Sunday. In purple, we subtracted the 13 from Sunday. In red, we're going to subtract the X variable, which was the number of inches on Sunday. So how about we subtract X, which was our Sunday number, from the 21 total. And if we do that, we'll get not a number, but something we call an expression, and it's going to have X in it. You guys write down what that is? It's a few symbols. One of them is X. All right, let's see some hands. Somebody we haven't heard from yet today? Right here? 21 minus X. Other thoughts? Does that seem okay? Yes?
Would it be fair to use Y as well?
Y is perfectly good. What are you thinking?
I put down Y first, and then you said
Okay. Oh, right. So, yeah. So what's your name? Evan. Evan thinks maybe we put a Y over there and an X over here, and that's totally fine. We still need to capture the fact that on the 2 days total, we had 21 inches of snow. So Evan's idea of introducing the two letters is perfectly good, but there's actually an equation that we're going to put down here that relates the X and the Y and the 21. Ben.
So I used 21 minus X equals Y.
21 minus X equals Y. Perfectly good. Maybe, yeah, if you add the 2 days, you get 21. That's a perfectly reasonable way to write it. So we're going to be interested a lot of times in trying to avoid having two variables, but we'll also have many techniques where we use the two variables. So perfectly good, but I'd also like us to be able to do it with only one if possible. Yeah. Okay, so let's move on to number 3. And I'll just say, for some of you, I'm sure this feels like it's slow motion. And I apologize. I know that some of you could have just gone right to x and 21 minus x without all the number stuff at the top. The only reason that, that we want to go through the numbers is that I assure you the problems will get more complex throughout this semester. And I expect that for most of you, we'll get to a point where you can't just take a word problem and then jump right into the algebra and right away know what the equations are with x or what the expressions are with x. And this is a way to get started. This is helpful if you don't know how to begin, is just plug some numbers in, see if you can figure out the pattern. So even if it's easy for some of you for these, I think it's worth our time to try to put the numbers in and fill in the boxes. Okay, we'll go to number 3, and is it Teresa? Can you read number 3, please? It was the big packet, yeah, right there. Okay, so we'll go to here for 3, go ahead. Okay, thank you. So can you guys do the same kind of thing as before? Pick a number or 2, probably 2 is better than 1. Fill in here, write out something with words in it, not just symbols, and then another number in the last column, and then see if you can generalize at the bottom. If you don't know the names of the people sitting next to you, this is a good time to find out, and then work with them. So in my first row, I've made up an example where I just said, okay, what if I have 4 nickels in my pocket, just to pick a number? A lot of you pick different numbers. So how do I find out how many are dimes? Well, I take my total coins, which is 9. I subtract the number of nickels, which I made up, is 4, and I get 5. Okay, I'm not going to write another one, but hopefully you've got at least 2 in there so you can find the pattern. And then once we've got the pattern, perhaps we can go to a variable. Now, x is a perfectly good variable to use in like every single problem we do this semester, but I think it might be better in some cases to use a letter that's more representative of the thing it represents. And so I saw in the back corner there, Davis had suggested using n here. And I think that's a great letter to use because n gives me some idea that I'm talking about nickels. So I take my total, which is still how many coins? Still 9. And then I subtract the number of nickels, which we've now generalized to n. And so 9 minus n is our expression for the number of dimes. Okay? Okay, let's move on to number 4. Okay, so we're going to go back because we skipped you before. Number 4. Okay, so not so much about the number of coins, but actually the value of all the coins in your pocket. Do you have like $1.25 in your pocket? Do you have 75 cents in your pocket? What's it worth in your pocket? So let's see if we can figure stuff out here for value. So let's do the same kind of thing as we did up above. So how many nickels did I start with in my number example? I started with 4. So I'm going to put a 4. I'll do the same color here. So I'm just going to put a 4 just to pick a number. And then what's the value of a nickel? It's 5 cents. And it seems like cents is the right place to go. And so what's the total value of all those nickels in my pocket? It's 4 times 5, right? It's 20 cents. So I'm going to say 4 times 5 is 20 cents. Okay, and just while I'm thinking of it, there were some people that I didn't check the homework that were here Friday, but I didn't get to do it right before class. So if you have homework to show me and I haven't looked at it yet, please stick around for a minute right after class. This is also a good time to say that ignoring the snafu from Friday, I do have a 1-day grace period on my homework all the time, regardless of whether you're here or not. So you always have an extra class to turn things in, all right? So I'm going to assign homework at the end of today that is technically due on Wednesday, but I'll give it to you. I'll give you full credit for doing it as long as you do it by Friday. Okay, so there's always a one class grace period. Okay, so that's fine there, and let's jump down to the number of dimes. So we'll keep this in purple actually. So if we had, how many dimes did I have in my top row there? I had 5 dimes, so I'll put a 5 up here. And what's the value of each dime? 10 cents. And so go ahead and fill in a number there in the last column. If you have 5 dimes, total value of those dimes is 50 cents. So again, multiplying those two things. So we have 50 cents. Super. Okay, that's the arithmetic version, the number version. Now we make the big leap to the algebra version. Let's use the same letters that we used up above, or that I had up here from Davis's suggestion. Number of nickels, what letter are we using? N. If there are n nickels, what can I throw down here for the number of dimes? It will have n in it. I don't want to put a d, I want to keep the same variable. It's the 9 minus n that we did work for. If you have n nickels, that whole row in red there tells you that the number of dimes is 9 minus n. So I can put down here 9 minus n. And then we can shoot straight across each row just like we did before. So if we multiply in the first red row, I get 5 times n, or 5n. And then in the bottom row, it starts to get a little bit more complex. So 9 minus n times n. You can leave it like that. You could also simplify it maybe by distributing. The 10 can go through the parentheses. 90 minus 10n. Any questions on either of the red rows? Okay, and then one final expression for the total value of all the coins. What am I going to do with that thing and that thing? I want the total value. What are we doing with those two things? We're going to add these two things together. I think it's important to really understand what that 5n is telling you. I understood what 20 cents was. 20 cents was how much money I had from the nickels, the value of the nickels. 5n is the value of the nickels. And 90 minus 10n is the value of the dimes. So we're going to add them together and get our total value. So I'll say TV for total value. And the total value is just the two yellow things added up. Yes?
Would it be fair to do 9 minus 5?
Absolutely. So the suggestion here is to combine like terms. That's always a good idea. So how many n's do we have when we combine those two guys together? So negative 5n. So 90 and then subtract 5n. That's it. That's the total value of all the coins in your pocket. 90 minus 5n. And I think once you take the time to make this leap from the arithmetic to the algebra, it's always a good idea to check your final algebra thing and just see if it makes sense. Because you can make a little mistake and then get something that is just, there's no way it's possible. But you wouldn't know it unless you checked. So for example, again, in my first row up here, how many nickels was I picking? I was picking 4. 4 is n. So what I might do is plug in, for example, 4 instead of that n. Can you guys figure out what's in that blue box if 4 places the n? It's 90 minus 5 times 4. What does that equal to? 90 minus 20, which is 70. Everybody see what we did to get 70 there? 90 minus 5 times 4. 90 minus 20, that's order of operations. 70 cents. Is that right? Look at the purple numbers. I had 20 cents from the nickels. I had 50 cents from the dimes. How much total? 70 cents. Worked. Makes sense. All right. So let's move on to number 5. Can we go to Jordy? Say it again. Jody. Oh, there's no R? Oh, I thought there was an R. Jody, I apologize. Go ahead. Okay, thank you. Ben, number 6.
Example 2.
Triathlon.
Triathlon.
Okay, thank you, Ben. So let's give this a shot. We've got a triathlon. It's got 3 pieces, swimming, cycling, and the running. And then there's some information given to us up here. Okay, well, I don't really know maybe how to get started. Some of you might know how to get started. But if you don't, picking numbers might be a good way to get started. So let's see if we can really process what's given here. It says the run is 11 times as long as the swim. That seems to be important. And then the cycling distance is 85.8 miles longer than the run. So those are the 2 things that seem to tell you how the different parts of the event are related to each other. And somehow the total distance is going to be important too. But let's suppose that I really just don't know how to even begin. I don't even know what letter I should pick to be my variable. Like, what should X stand for? Well, it could represent how far you swim, or it could represent how far you run. It could represent how far you cycle. And I think one of those choices is going to make this a really easy problem, and the other 2 are going to make it quite a bit more difficult. So how about we just read these things, see if we can pick some numbers, and then go from the number, the arithmetic, to the algebra. So the first sentence in green there says the run is 11 times as long as the swim. The run is 11 times as long as the swim. One of those 2 guys seems to be the kind of independent thing, and the other one seems to depend on it. I'll say it again. Run and swim. One of them seems to be independent, and the other one seems to depend on it. Are you guys clear on which one is which? So 1 vote for run depends on the swim. Second vote, a few more votes for that. I think that's right. I think if you know how long the swim is, like let's say I tell you the swim is 2 miles. How long is the run? It's 22, right? It's pretty easy to go that direction. But if I tell you that the run is 2 miles, to figure out how far the swim is, well, that's not as easy. You'd end up having to divide by 11, which isn't what, it doesn't say anything about division there. So it feels like swim is underneath, kind of the independent thing. And let's go ahead and read. So I'm actually going to draw a little thing here. So I've got swim underneath the run. Run depends on the swim. So I'm going to put arrows here. Run depends on the swim. And then the blue sentence, it says cycling is 85.8 miles longer than the run. One of them depends on the other. Does cycling depend on the run, or does run depend on the cycling? Yeah, it feels like it's telling you the cycling distance is something, something, something to do with the run. So I'm going to keep drawing my arrows here and put cycling above the run. If I tell you, for example, the run is 20 miles, what would you do to find the cycling distance? You'd add the 85. So it's pretty straightforward. That's what it says. But if I told you that the cycling distance was 100, well, you'd have to really kind of think, yeah, you'd have to turn this into a subtraction. The word longer to me seems to say add, so I feel like we're picking the right direction here. So I think this is the right direction. So for example, let's just make up a number here for the swim. If I told you that the swim was 2 miles, can you guys see if you can work your way back, figure out how much the run is, and then figure out how much the cycle is? Check in with your neighbors on this. If the swim is 2 miles, how long is the run using one of the highlighted things? And then how long is the cycle using the other? Okay, let's see how we did. If the swim is 2 miles, how long is the run? 22, right? The run is 11 times the swim. So that's by, I'll put a little symbol here. We multiplied by 11 in order to get up there. And then the cycle is 85 more than the run. So what do we do there? We add 85. So let's put that. So we say add 85.8. And that gives me how much? 107? 107.8. And that feels okay. Cycle is 107 and change. The run is 22. The swim is 2. Great. Does this satisfy the last thing in the problem, which is that overall the competition needs to cover 140 miles, which is crazy to me because like driving 140 miles feels very far to me. But the triathlon covers it by foot and swim and pedal. So no, it doesn't, because if you add these guys up, you get, like 130-ish, which isn't quite enough. It doesn't quite get us to the 140. So how are we going to get there? Well, if you have a lot of patience, you could fiddle with the 2 that we started with. I just picked the number 2 out of a hat. But if 2 isn't enough, then maybe try 3. And then recalculate all the cycling and running distances and see if it magically works out. And if it doesn't, then try 4. Or if it's too big, if 3 is too big, maybe 2.5. I'm not such a fan. I mean, trial and error is a great process. But if the right answer to this question is 2.864, it's going to take a long time with trial and error to get to 2.864. Yes?
Yeah.
So let's see if we can use the algebra here to help us. So the thing that we picked for this 2 miles was the swim. That was where we started, and it felt like everything depended on the swim at the bottom here. So if we're going to pick x to be a variable, it feels very natural to me that we're going to change, instead of 2, I picked out of a hat, we'll change it to x, or maybe s for swim. Jody. The 107 was the 22 miles, which was the run. And then up here in blue, it says that the cycle distance is 85 longer than. So we added 85 to the 22. So it feels to me like the variable is sitting here at the bottom with the swim. So let's start there. So I'm going to let s equal. Now, I don't want to say just the swim. It's tempting to just say let s equal swim. But the variable has to represent a number of something. Variables always represent numbers of something. The swim is a physical activity. It's the length of the swim in miles. That's what we're after. So let's put that in here. So length of the swim in miles. And I know that many of you come from Sandy's Math 105 class, and I know that she did a lot of work on stressing the number, the quantity, and the unit. And we've got both of them up here. So the quantity is length, and the unit is miles, and we've got them both. Okay, so then if that is the length of the swim, then how did we get from the swim to the run? Well, what did we do here? We times it by 11. And I feel like that's exactly what this green highlighted sentence says. If you know the swim, then the run is 11 times as long. The swim is now s, the run is now 11 times s. And then 11 times s. You guys good with using a dot for multiplication? It's familiar? Great. So 11 times s is the length of the run, also in miles. Okay, and then we've got one more piece of this puzzle, that's the cycling part. So before we added 85.8 to the run. Let's see, I think that's what the blue says. It says the cycle is 85.8 longer than the run. So we're going to take whatever we had for the run, add 85.8. Yeah, so the length of the run, we've got it right there. It's 11s. I don't want to introduce r. It's not wrong to introduce another letter for the run. You could introduce a third letter for the cycling part. But the idea here is if you can avoid that, then you're going to get an equation that you can solve much more easily than having an equation with, say, two or three different letters in it. So the last piece of this puzzle is that whatever the run is, I'm looking at the blue again, whatever the run is, the cycle is 85.8 longer. So the cycle is 85.8 longer than. So I've got a little blank there. We'll fill it in a moment. But what we're after is the length of the cycling distance. It says 85.8 longer than the run. What was the run? It was 11s. You could call it R, but you're kind of cheating yourself. You're not using all the information if you just bring in another letter. It's 85.8 more than the run. The run, because we've written it out so clearly, is right up above. 11 times S plus 85.8. So we now have all three of the pieces, the swim length, the run length, and the cycle length, all in terms of one letter, and that's the key. So the last thing is to write our equation. It says up here in yellow, the total competition covers 140.6. So I've got my three things, and it says the total of those three things is 140.6. Can you write an equation and then solve it? Go ahead and write an equation and then solve. Wonderful. But let me just interrupt for the last 2 minutes of class here. So you guys are currently working through this group activity. At the end of most classes, we're going to hopefully have a good chunk of time for you to work together. I have not mentioned my name for the people that that just met me today, and I'm not going to mention my name because my name is not the most important name you're going to learn today. More important than my name are the names of the people around you. So take 30 seconds and learn the names and write them down. Go ahead, ask people who they are, learn their names. Okay, and I know it's very difficult to learn names. You're not going to see these people again maybe for 2 more days from now, and you probably will have forgotten some or all of their names by then. The good news is if you're too embarrassed to ask them again what their name is, there's a little cheat sheet right on the folder in front of you, okay? Just give a little casual glance. You'll know exactly who you're talking to. Okay, if you take a look at page, whatever page this is, the number I think is crossed out. It should be page 11, although you're going to have a hard time finding the page number. But find where page 11 should be. And I just want to be crystal clear about what I'm expecting from all of you on Wednesday. Everybody see page 11? Page number is behind a graph, but it looks like this at the top. Okay? So, page 11, we see a familiar phrase, learning objectives after class number. We just finished class number 2. There is a reading assignment from the textbook. There's something specific happening on pages 50 and 51. You're going to make note of that. There's the group activity, the shopping spree that you are currently working on. I know there was not enough time to do that whole thing. Finish it between now and Wednesday. It's a really good exercise. And then finally, the stuff that I'm going to be collecting, well, not collecting, but checking, and I will be giving points for on Wednesday are these two things right here in the textbook, okay? Pay attention to the page numbers. The book that we have is special to GCC. It's not always clear where things are. So the page numbers here hopefully will help. If I ever make a mistake on the page numbers, and I know I will because I typed a lot of stuff for you guys over the break, please let me know and I'll fix it for next time and I'll let everybody else know. Okay, we will see you on Wednesday. Have a great day. Yes.